do 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 do, baby shark do 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 do, baby shark. Mommy shark do 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 do, mommy shark do 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 do, mommy shark do 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 do, mommy shark.
Daddy shark do 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 do, daddy shark do 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 do, daddy shark do 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 do, daddy shark.
Grandma shark do 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 do, grandma shark do do.
The skin of the shark is composed of two layers, like humans. It's got the epidermal layer on the outside and then the dermal layer on the inside. And extending from the epidermal layer is the placoid scales. This gives it a rough sandpaper sound, and if you listen, you can kind of hear it.
Okay, so this is the anterior dorsal fin. These are pectoral fins down here. These two.
Oh, and it's called cloaca.
These two are the pelvic fins. This whole tail is called the caudal fin. This is the dorsal lobe of the caudal fin and the ventral lobe of the caudal fin. And this is the posterior dorsal fin. Sharks have a heterosural tail, which means the dorsal and the ventral lobes are asymmetrical. The pectoral fins and pelvic fins provide lift to counteract the shark's natural sinking body. The dorsal fin and the caudal fin propels the shark forward. These are the gills right here on both sides. Oxygen from the gills enters the circulatory system through deferential brachial arteries. Oxygenated blood travels to the rest of the body through the dorsal aorta.
So here you have the shark's mouth, and you can see the multiple rows of teeth. So new teeth grow from the inside, and older teeth are pushed towards the outside until they eventually fall out. Okay, so here we have the esophagus, and then this begins the stomach. You can see the J shape. The outside of the J is called the greater curvature, and the inside is the lesser curvature. So now we'll cut open the stomach.
Digestive breakdowns of food, and you can still kind of see that there's still pockets of food in here from being digested. And the stomach still has large, copious amounts of gastric contents. Yeah. Sorry, I don't know if we talked about that.
So now inside we can see the rugae, which give the stomach greater surface area so it can better absorb nutrients. So here you can see where the esophagus connects to the stomach. So here we have the spleen attached to the stomach, and then the intestine. So here inside the intestine we can see the spiral valve. So here with the gallbladder, it's attached to the underside of the liver. This is where bile is stored. So here we have the shark's liver. It consists of 3 lobes. Here we have the right lobe, the medial lobe, and the left lobe. Unique about the shark's liver is it's highly rich in oil, which provides some buoyancy when the shark is swimming, and it's also how the shark stores its energy rather than storing fat.
The heart is made up of two chambers, the atrium, these two dark pieces, and then the ventricle. The ventricle is the muscular portion that pumps blood, and the atrium is the relatively non-muscular portion, and it receives blood from the sinus venosus. We'll remove the heart. And dissect it. The atrium.
And see, like, this is the cloaca, so they're real close to the bottom. If you would like that, that is a test.
Two lobes of the atrium.
What you'd be pointing at be the test. Would it really went up that high?
Are there other identifying features that you know?
And then the ventricle.
On this, we can find something.
Deoxygenated blood is collected in the atrium, where it is then sent to the ventricle. The ventricle pumps the deoxygenated blood through the arteries to the gills to get oxygenated. After the blood gets oxygenated, it is then sent throughout the body.
Alright, and right here you have the ampullae of Lorenzini. These are bioreceptors that detect weak electrical signals in the water. This allows for sharks to find prey in the water or in the sand. They also sense water temperature change and temperature and the pressure, and they can be seen in these dark pores right here. Alright, so we have the brain right here. You're going to have your olfactory lobe and the tract, and it attaches to the cerebrum. And here you have the cerebellum, and then below that is going to be the medulla oblongata, and the pons is located on the ventral side behind the cerebellum. Alright, so we have the different parts of the shark reef. You have the telencephalon, which contains the olfactory bulbs, the tracts, and then the lobes, which are all on the inside, and then the cerebrum, which is attached right here. The olfactory structures translate chemical odors into information for the shark to know its surroundings, and then the cerebrum is responsible for the motor coordination. Alright, in addition, you also have the mesencephalon, which is also in this yellow part, and it also contains the optic lobes. And then you have the metencephalon, which is the cerebellum, which is this pink part right here. And then the ventral is on this side is where the pons is. The cerebellum is responsible for balance and equilibrium. It also is responsible for motor coordination and muscle tone, whereas the pons relays the messages between the two halves of the brain. And you have this cream color right here is where the medulla oblongata is, and that's responsible for all your autonomic functions, so respiration, blood circulation, heart rate, and swallowing. Alright, and here we have the lateral line, noted by this dark line going across the inside of the skin. This is responsible for helping the sharks locate their prey. It can detect water pressure changes, the temperature, and the movement in the water.
So here we have the testes, followed by the ductus deferens, and then we have the seminal vesicle, and then here we have the rectal gland, and then down in here we have the sperm sac. So here we have the cloaca. This is the shark's single excretory opening. This is where liquid and solid waste come out. This is also where reproductive fluids are exchanged. Our shark is male, so it has claspers, and the shark will insert its clasper into the female's cloaca, and the seminal fluids flow down the groove in the clasper.